Okay, so today we are going to work on combining like terms. So we have a problem. The cost of a jacket, J, after a 5% markup can be represented by the expression J plus 0.05 J. And so I wanted to go over a few vocabulary words just to make sure that we're good. So the first one is a term. And so anytime that we are using addition or subtraction to separate values or variables, quantities or variables, we call that a term. So in this problem here, this expression, we actually have two terms, J, and then we have 0.05 J. Now, what we're going to be able to do is use like terms. And a like term is a term that contains the same variable. So in this case, we have J, and they are raised to the same power. Well, we don't see a power, so we know that it's raised to the first power. So in this case, they are considered to be the same power, or they're considered to be like terms. Another way to look at it is think about like a bin. Okay, and you may have different types of bins. This one we'll call our J bin, and we're going to use our variables to determine what type of bins that we have. So let's say that we had one that just had like numbers, and then maybe let's say that we added some other value. Okay, I'm going to call this X, and I'm just going to write just a simple expression. So let's say that we wanted to know what 2J plus 3X plus 4 plus 4J plus 2 plus 5X. Okay. And we wanted to simplify this. We're going to see problems where we're going to actually be doing this. Basically, what happens is we look at the variable and I see that we have a J. So that goes into the J bin. And because we are talking about rational numbers now, we should be using positives and negatives so that we understand basically if we're adding or subtracting. Okay. So this is plus 2J. That goes in the J bin. We have 3X. That's a positive. 3X. We have 4. That's a positive. So that goes into our constant. And then we have a 4J. That's a positive. So plus 4J. And then here we have a 2. That's a constant. Positive. Oh, wrong bin. Okay. So that's a plus 2. And then we have a 5X. So plus 5X. Okay. And so what's going to happen is once we use whatever operation applies to each of those bins or those values that are inside of the bin, you're just going to simplify it. So I have 2J plus 4J, which means that this would end up being 6J. And then I have a 4 plus a 2 here, which means that this is going to be a 6. And then I have a 3 plus a 5X's, which means that this is going, that's not 15, that's 5. Which means that that's going to be 8X. Okay, so if we was to simplify this, we would say, oh, okay, well, 8X plus 6J plus 6. And where am I getting like the plus and things like that? Because remember, these are positive values, okay? And if we don't see a sign in front of it, we know that it's positive, right? So we don't see a sign in front of this 8, which means that it is positive. So let's solve our first example to see how that would look. So let's go in and figure that one out. So they tell us the expression is going to be J plus 0.05 J. So notice we have the same variable. They're raised to the same power, which means they will both go into the J bin, right? So we're going to say this is J. And so we have a J, but there's no number next to it. So remember, if there's no number next to it, we know that that means that there's one J there, right? And then here, and that's positive. And then here we have 0.05. That's also a positive because there's a plus sign in front of it. So we're going to say plus 0.05 J. So all we're doing is adding those two values together. So in other words, what is 1 plus 0.05? Well, if we add that up, we end up with 1.05. And then what was the variable? What bin were we talking about? J. So this is your answer, 1.05 J.